Good morning, everyone. Okay, so let's start. So you have been given these important points yesterday, right? Which once again highlight that you can write all of these quantities in form of the components, right? So we're writing position in form of components, right, in 2D or 3D. Then accordingly everything, displacement, velocity, acceleration, they're all going to be in form of components, right? Okay, and once again the key thing to remember, is that the two axes, they're going to behave independently. That is, you can just consider this to be two different motions, one in x-axis, one in y-axis, right? Okay, one in x-axis and one in y-axis. Yes, I only did send the important points. Okay, there was no homework, right? Homework will come very soon. Okay, hopefully today I'm going to give you a lot of homework. So now let's continue from there, right? Let's continue from there. Equations of kinematics. Now, you might think we have already studied it. Yes, we have, right? So, in fact, if you realize everything that we have studied in this chapter, we have studied it earlier: position, displacement, velocity, acceleration, બધું આવી જ ગયું છે, right? Okay, so now this time we are going to do it in 2D or 3D. So listen to this very carefully. If acceleration vector is constant, if acceleration vector is constant, okay, that this is acceleration, right? It's a vector, so it's a constant, right? Then what we can do is we can say that this means the x component of acceleration and the y component of acceleration, the x component of acceleration and the y component of acceleration, both are constants. Why are both of these constants? Because this whole thing is a constant, right? So in such a case, if we want to write equations of kinematics, then we can write it we can write the equations of kinematics separate on both axes, that is on x and on y. So what do I mean? I will have to write the first equation of kinematics for x axis as Vx equal to V0x plus AXT. Did you understand what I have written? It is important to understand the terms, right? So V generally stands for final velocity. Here it is Vx. Vx means final velocities, x component, right? This is, yes, I agree, this is V equal to V0 plus AT, right? There is no doubt about that. This is V equal to V0 plus AT, but we are using this for x axis. So Vx is the final velocities x component. Okay, then similarly V0x is the x component of initial velocity, right? Ax stands for x component of acceleration. And I think some of you are going to have a question. Shouldn't we write Tx? Then I'll say no. Right? Okay. So I hope you have understood why you can't write Tx, because time is a scalar. Scalars do not have components, right? Yes, time is a scalar and scalars don't have components. Only vectors have components, right? Okay, so don't write Tx. Similarly, suppose I want to write the first equation for y-axis. Suppose I want to write the first equation for y-axis. Then it is going to be Vy equal to V0y plus Ayt. I hope I don't have to explain the symbols now, right? Okay. Right? So this is how you write the first equation. Now suppose you want to write the second equation, right? If you want to write the second equation for x-axis, how would you write it? Delta x equal to v0 xt plus half ax t square. I hope that is clear. So what is delta x here? Come on. Can you tell me the meaning of delta x? Can you tell me the meaning of delta x? Displacement is not correct, not correct, not correct, not correct. નો ફલક. હજી સુધી કોઈનું જ સાચું પડ્યું નથી. એક પણ જણનો આન્સર સાચો નથી. વેરી ગુડ જયકિત, યુ આર ધ ફર્સ્ટ વન ટુ ગીવ ધ કરેક્ટ આન્સર. ક્રીમા કાવ્યા, ઇઝ ઇટ સ્પીડ? કમ ઓન, સ્પીડ માટે કોઈ ડેલ્ટા એક્સ યુઝ કરે? ધર્મી, નો વે. રિઝલ્ટન્ટ, અરે આને થોડું ડેલ્ટા એક્સ ઇઝ રિઝલ્ટન્ટ. કમ ઓન people, you are not reading your notes. You are not reading your notes. It's not distance forum. Delta x means x component of displacement. અરે યાર, કાલે લખાયું. આ શું લખ્યું હતું આપણે? અહીંયા જોઈ લો. આ શું છે? આનો શું મીનિંગ થાય? કેમ યાર વાંચતા નથી હો તમે લોકો? Yes, Ayush. Only few people gave correct answer. Most people got the answer wrong. Okay, so that's why I have to criticize you all for that. આ જો આ શું છે? I hope everyone understood that. Is this clear now? Delta x is the x component of displacement. Yes or no? દેખાય છે ને આમાં, આ ફોર્મ્યુલામાં, કે નથી દેખાતું? I hope everyone is well awake. 3 જણને ખબર પડી એટલામાં, બાકીના 89 ને ખબર નથી પડી. સોરી, 85. People, please read your notes. આ ઇમ્પોર્ટન્ટ પોઈન્ટ હું તમને એટલે જ લખાવું છું કે આની બહાર તમારે કંઈ ફિઝિક્સમાં વાંચવું જ ન પડે. અને હવે વેક્ટરના એક્સ કોમ્પોનન્ટ, હા એ છે. આઈ હેવ નોટ મેડ યુ પ્રેક્ટિસ આઈડેન્ટિફાઈંગ એક્સ કોમ્પોનન્ટ, વાય કોમ્પોનન્ટ. મને તો લાગ્યું તમને આવડી જશે એમને. ચલો કંઈ વાંધો નહીં. I hope next time you'll do better. Okay, let's come to this one. What is meaning of this? ચલો આ symbol નો meaning બોલો. What do you think V0x is? What is V0x? Everyone, it is okay to be wrong. ક્યારેક ખોટું પડવાનું જ છે. If you don't give answer, you will not know that you are wrong. Okay, અને સીધું એક્ઝામમાં માર્ક કટ થઈ જાય ને ત્યાં જ ખબર પડે, લે આ તો મને નહોતું આવડતું. Initial velocity of x component nahi, please. X component of initial velocity. Everyone, this is fine. this is initial component, sorry, this is the x component of initial velocity. I hope that is clear. Initial velocity of x component no kay meaning no થાય. Okay, if I would say suppose let's say Mitesh, okay, કોઈનું નામ મિતેશ નથી લગભગ તમારા ક્લાસમાં. So if I would say Mitesh, raise your left hand. Okay, very good, make some sense. If instead of that I'd say left hand, raise your Mitesh. So this is exactly the difference between those two sentences, right? તમે એમ કહો initial velocity of x component આ આના જેવું છે, and the correct thing is x component of initial velocity, that is like this, which is right. Okay, so please say it the right way. Okay, આ ખાલી મજાકની જેમ કીધું પણ આવું બધું કન્ફ્યુઝન હોય બધાને હોય એટલે થોડું ધ્યાન રાખવું પડે. And ax is the x component of acceleration, right? Okay, now for y axis, who can tell me what we should be writing? આખી equation તમે લખીને બતાવો તો ચલો, write the whole equation on your own. Can you write the equation? I know it's a bit complicated to type. Can you write the whole equation, everyone? Okay, lots of people are giving correct answers. Very good, very good. See, you don't write y axis equal to, you write delta y equal to. Okay, ay, you mean delta y? Yes, so everyone, the equation is going to be delta y is equal to v0 y t plus half ay t square, right? This is again the same equation that we used to write. Okay, now here I'm going to ask you, can you name this? આને શું કહેવાય? What is its name? What is its name? So this time most of you have done it right. Tell yes Ami, well done forum, well done Ankita. હવે બધાનો આન્સર સાચો આવવા માંડ્યો. અરે વાહ, બધાનો આન્સર સાચો છે. Jaikit, you did that same Mitesh kind of mistake. It is y component of displacement. જેમ delta x is x component of displacement, this is y component of displacement, right? Components nahi દેવર્ષ, component, it is only one, right? Singular છે. મને પાછી ગ્રામર ની એ બહુ તકલીફ. Okay, so that's for number 2. Now if you want to do it for number 3, the third equation for x axis. હવે આમાં કઈ હું તમારી રાહ જોવાનો નથી. I'm just going to write it, okay? I'm sure all of you will understand. I don't have to worry about it. Right? So this is it. Okay? So what have we learned new in this topic? ઠેંગા, nothing. આ તો બધું પહેલાથી આવડતું હતું ને, ખાલી components લખ્યા. I hope you get what I'm saying, right? We have not learned anything new here. We have not learned anything new in this topic, right? We are just doing everything in form of components, right? X and y. Yes, again, you look at this equation. this equation and this equation. So when you are writing the equation for x-axis, you don't really get anything for y. Whenever you are writing equation for x-axis, we don't get anything for y. So this is what I'm saying, that motion in x and motion in y, they are two separate or independent motions, right? These two are two separate and independent motions, and when both of these motions combine, we get motion in a plane, right? Motion in a plane, right? Okay, yeah, no problem with that. I hope you understood the whole philosophy of independent, right? Okay, now see, although I've not proven these equations, you can actually prove these equations also, right? Okay, and you can write these equations in vector form. Okay, so just let's go to the next page. I hope everyone has noted whatever they wanted to note, right? I'm going to the next page. So if you want to write equations of kinematics in vector form, okay, in vector form, right? So we can write the first one as this. That's it. આમાં બધું આવી ગયું. You might be wondering how. Let's have a look. Instead of v, I can write vx I caret plus vy j caret. Okay. Instead of v0, I can write v0x I caret plus v0y j caret. And instead of a acceleration vector, I can write ax I caret, and then you see what we are doing is we are simply going to follow the rules of addition. I hope you remember that x component adds with x component. I hope everyone remembers that, right? And plus, now for y component, this one, so that's going to be v0y plus ayt j caret. Now it's a very peculiar situation. It's actually very interesting because there are two things here. It's like if someone is going to tell you, like maybe ai caret plus bj caret is equal to 3i caret plus 2j caret, and then they'll say find a, find b. What do you think will be your answers? What do you think will be your answers? What do you think will be your answers? Come on. Intuition. Okay, it's very simple. મારે કંઈ શીખવાડવું પડે એવું નથી actually. It's very simple. Yes. Dia, what are you doing? The obvious clear answer is that ai caret should be 3i caret, so a is 3. bj caret should be this, so that should be 2, right? Okay, I hope no one found this tough, right? So use the same idea here. There is equal to, on left side the x component is this, on right side the x component is this. So compare them. So you could just write comparing components. Okay, comparing components, vx is equal to v0x plus axt, right? Okay, so this is the form in which we wrote that. Okay, and similarly if you are going to compare the y component over here, so you are going to get vy equal to v0y plus ayt. આવું બધામાં નહીં કરી દઉં, એકમાં શીખવાડી દીધું, બાકીનું તમે જોઈ લેજો. ઓકે, રાઈટ? right? So the second equation will simply look like this. Second equation will look like this. I know you're going to say, sir, this is same. Yes, it is same. खाली ऊपर छापरा आवेगा because these are vectors, so they must wear their own uniform, right? Okay, I hope you understood this, right? And I'm not going to write it in form of components. Also, the third equation, uh, the third equation should be written like this, and you write it like this only. I will not explain the reason right now. Okay, reason we will cover in chapter 6. Okay, you write this equation like this only. Okay, જ્યાં હું dot કરું તો તમે dot કરજો. No liberty, anyone. Must write it like this only. Nandini, you can, if you want, you can simplify it. You can simplify it in form of components. Okay, but that is for you to do, right? I am not going to write it. If you want, you can do it. I don't mind. આપણે અહીંયા લખી જ છે પહેલા. Okay, here we have already written the second equation in form of components. So okay, so in the third one, we are seeing this weird kind of dot here. E આવી રીતે નથી, please. This is wrong. Let me tell you that this is wrong. I know some of you might say આંબાઈમાં કઈ ફરક જ નથી. ધ્યાનથી જોવો ફરક છે. Okay, but what does that dot mean? What does that indicate? That we will cover in chapter number 6. Okay, generally I teach it while teaching the 4th chapter, right? But at the particular, I mean in this year, I'm not going to do that. Okay, because you all are not in front of me. There are some things that I'd like to explain by using board, the pen and everything. Okay, but I can't do it here. Okay, so right now we just put it. See, we don't use it. We will not use it like this. Okay, right? We don't use it like this. We use it like this always. This is the way to use the third equation because it is easy, right? Okay, fine. Now let's solve questions based on this, right? Let's solve questions based on this. There is a good example in the book, right? Let me just find it and we will solve that one. Okay, 4th chapter. All right. Example 4. Example 4. All right. Okay. So here, this is dhokha actually, right? This is treachery because the chapter's name is motion in a plane. And here they have given it in 3D. Actually, this is not changing. So you could still say it is in a plane, but you just have to be careful. Okay, anyways, let's start. It doesn't matter whether r is in 2 dimension or 3. So r vector is given. Position of a particle is given, right? How, and it is given by this vector. Okay, so this is equal to 3. આમને પાછું significant figure નું બહુ 3t I caret plus 2t square j caret plus 5k caret. Okay, this is given. Now first of all, this is position vector, correct? This is position or position vector. Can you tell me what is the x component? People, can you tell me what is the x component? What's the x component of this position vector? Give your answer. What's the x component? Yes, very good. People have started identifying. That's very good. Okay. What's the z component now? What's the z component? What is the z component? 5. Yes. 5 is the z component and 3t is the x component. There is a ridiculous amount of noise around my house. I can't believe it. Now, because usually at this time I'm in the school, right? So I don't get to hear all these vehicles. Okay, so where t is in seconds and the coefficients have proper units, chalo. So this equation is dimensionally correct. Okay, it is given that this equation is dimensionally correct. R to be in meter, find v of t. Now see, what is meaning of this? Bold che, vector. Okay, v of t means we have to find velocity, its formula. Right? We have to find velocity is formula, right? That is how it depends on t. So from position, how do you find velocity? From position r, okay, not x anymore, r. From position, how do you find velocity? Get in some airtight room. તો પછી શ્વાસ કે દે લેવાનો. Write the equation, everyone. Write the equation. Kavya, no. Symbols have changed in this chapter. વેદાંત હવે તું આ સોલ્વ કર, નહીં તો તને મૂકી દેશે એવા રૂમમાં. રોંગ રાહુલ, ઇટ ઇઝ રોંગ. યસ કાવ્ય, નાવ ઇટ્સ રાઈટ. અરે બાકી બધા ભણે છે કે નહીં? સુઈ ગયા કે શું? ક્યાં જતા રહ્યા? Only 10 to 15 people are answering. જો તમારી ચેટ છે ને સેવ થાય છે, બરાબર? તો હું છે ને આ લેક્ચર પૂરો થશે ને એટલે જે લોકોના નામ ચેટમાં એટલીસ્ટ 2 વાર આવ્યા હશે ને એ લોકોને આપણે કાલે અલાઉ કરશું ક્લાસમાં, બાકીનાને રિજેક્ટ કરી દેશું. બરાબર ને? કારણ કે જૂનું ભણાવેલું નહીં આવડે તો આગળનું કેવી રીતે શીખશો? Okay. So now the correct answer is v vector equal to dr vector by dt. Okay, v vector equal to dr vector by dt. So let's put it here, right? So d by dt, instead of r vector, I'm going to write this big thing. Okay, so 3t I caret plus 2t square j caret plus 5k caret. Okay, normal rules apply. So this is going to be equal to, bolo answer Ano. What is this differentiation? Tell me, I'm waiting for you. What is this differentiation? Yes, Divya. Yes, your answer is right, Divya. Others, come on. No, ધ્રુવાંશી. ખાલી 5 ક્યાંથી આવે? કેટલું બધું કરવાનું છે? ફટાફટ ચલો કે હું કરાવું એકવાર. હું કરાવી દઉં, પછી હોમવર્કમાં આપીશ તમને 3-4, તમે રમતા રહેજો આખો દિવસ. No, Kavya, you're forgetting I caret, J caret. Yes, others, your answer is right. Very good. Five three શું છે ક્રીમમાં કાવ્યા? Rishabh, where is T? The correct answer is 3I caret plus 4T J caret plus 0. એટલે આ લખવાની જરૂર નહીં. Okay. So this is what you get, right? So this is V vector. You can see it depends on time. I hope all of you realize that this depends on time. Okay. Now we have to find A of T. A of T means acceleration. How to find acceleration from velocity? How to find acceleration from velocity? Yes, dv by dt. Do it, come on. Prasham, your answer is wrong. Yes, Divya, very good. I've started to get answers. Solve it, come on everyone. It is of course going to be dv vector by dt. So what will be its value? What will be this? Yes, it is going to be 4j caret, right? And see, this is in meter per second. Don't forget that. And this is in meter per second square, right? Okay. ધમકી બરાબર કામ આવી છે. There are many people who have started answering. Well done, all of you. People, please don't worry. I might criticize you for being wrong, but that's how you learn. તમે ખોટું કહો તો હું તમને થોડો હા હા વાહ 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 શાબાશ કહું, તો પછી તમને ન આવડે ને. અને કંઈ કહેશો નહીં તો મને ખબર નહીં પડે કે તમને આવડ્યું કે નહીં. In both things you are in loss, so there is only one correct way to learn. સર ટીચર સામે બોલવાનું અને ન આવડે તો સાંભળી લેવાનું અને બીજી વાર શીખી લેવાનું. નો આયુષી, because differentiation of constant will be 0. See, when you try to do it, see, there is no t in the first term, right? There is no t in the first term. So when you do differentiation of 3I caret, this is going to be 0, right? Because it's a constant. All right. Sanju, your question has been answered, right? Because 3 and I caret are both fixed or both constant, that's why its differentiation is 0. And here you'll get 4j caret, right? When you do it. Okay, so that's that for this particular part of the question. હજી કંઈક છે આગળ કંઈક ફાઇન્ડ કરવાનું છે. Find magnitude and direction of velocity at t equal to 1 second. Okay, let me take this below. Let me write the question. Let me find magnitude and direction of velocity at t equal to 1 second. Let's write the formula of v that we have here. Okay, this one. Okay, so that is v vector equal to 3I caret plus 4tj caret meter per second. First of all, magnitude of velocity. That is a known animal, isn't it? What is that called? Magnitude of velocity. What is that called? યાદ તો છે ને બધાને? હા, યાદ છે. Okay, આવડી ગયું. It is called speed, right? So now it is time to officially introduce the symbol of speed. Okay, big warning, lots of confusion coming up. Symbol of speed is this clear? Is this understood what I've written here? Look, why does it have this kind of symbol? Magnitude, vector A, its magnitude is either A or modulus of A vector, right? Just like that, vector V, right? Vector V, its magnitude is either this or this. એટલે હવે કોઈ પૂછે V is the symbol of, તો શું કહેશો? V is the symbol of, yes. Okay, so generally when we are talking about 2D or 3D, then we say that only writing V means speed. Okay, and writing like this means velocity. Okay, because velocity is a vector. Okay, so right, I think I'll have to erase a few things over here. So now we have to find its magnitude. Okay, I hope you will be able to remember the symbol and all that. આ લોકો એક સારું ઇરેઝર કેમ નહીં આપતા હોય આ સોફ્ટવેરમાં? Now, if you want to find magnitude, so what's the formula to find magnitude of a vector? What's the formula to find magnitude of a vector? If I give you a vector like this, what's the formula to find magnitude of the vector? Yes, it is under root ax square plus ay square plus az square. No, Ankita, you are getting confused between two formulas. This is magnitude of vector A and that formula was resultant. E બે અલગ છે ને? That was resultant magnitude of A and B. Okay, so I hope you will not get confused between this and this. Okay, so this is going to be, I hope that is clear. And t is equal to 1, isn't it? And yeah, so and t is equal to 1. So 5 આવી જશે. Okay, now direction. એકદમ simple. Direction. For finding direction of a vector, for finding direction of a vector like this, direction means we have to find angle. How do you find angle of a vector like this? લખાવી હતી ને એક formula. How do you find angle of a vector? Do you remember that? How do you find angle of a vector? Yes, Nandini, that's right.